A very pleasant evening to all distinguished panelists and participants. Bharti Vidyapeeth's Institute of Computer Applications and Management BVI CAM, in association with Computational Intelligence Society CIS chapter of IEEE Delhi section, Computer Society CS chapter of IEEE Delhi section, System Man and Cybernetics SMC Society chapter of IEEE Delhi section, Communication Society of IEEE Delhi section, Consultants Network Affinity CNA Group of IEEE Delhi section, Life Member Affinity LMA Group of IEEE Delhi section, Inter-Society Relations IRS Standing Committee of IEEE Delhi section, Industry Relation and Special Interest Group on Humanitarian Technology, Site Standing Committees of IEEE Delhi section, Region 10 of IEEE with the associations of Computer Society of India CSI, Institute of Information Technology Professionals IITP, ISTE Delhi section and IETE Delhi Center as technical collaborators. Welcome you all to this IEEE IETE BVI CAM technical lecture series on smart meters, advanced metering infrastructure. According to Fuji Electric France, smart meter technology has the potential to dramatically reduce energy waste, promote energy efficiency, and ultimately deliver significant cost saving for industry. In the ever-evolving landscape of smart world, advanced metering infrastructure is a cutting-edge system that revolutionizes the way utilities monitor and manage energy consumption. It integrates smart meters, communication networks, and data management system to enable real-time two-way communication between utility providers and consumers. By replacing traditional analog meters with digital technology, AMI provides accurate, frequent readings of electricity, gas, or water usage, empowering utilities to optimize resource distribution, detect outages, and improve the billing efficiency. This infrastructure lays the foundation for modern energy management, supporting sustainability goals and enhancing customer engagement through detailed usage insight. This webinar today will discuss the all-around perspectives of the advanced metering infrastructure. I would first take this opportunity to welcome amongst us our distinguished panelists for the day. We are privileged to have amongst us a galaxy of experts. I would first request Professor Emin Huda sir, Director, Bharti Vidyapeeth's Institute of Computer Applications and Management, BVI CAM, and Chairperson, IEEE Delhi section, to address the participants with his inspiring words. Over to you, sir.
Am I audible?
Yes, sir.
Yeah. So, good evening, one and all. At the outset, let me take this opportunity to welcome my two valued speakers today, the accomplished experts from their domain, Mr. Dheeraj and Mr. Vikas from Landiscale. Thank you so much, Mr. Dheeraj and Mr. Vikas, for having accepted our invitation and being with all of us on this evening on the platform of IEEE, IETE, CSI, BVICAM weekly evening Saturday webinar series. Dear friends, many of you are aware of this fact that this webinar series was started in the way back around 5 years ago in June 2020 in the backdrop of COVID-19, which has disrupted everything around us. And when it disrupted everything in and around us, we didn't know what to do. And the people were going in depression, people were becoming negative. So Bharti Vidyapeeth and IEEE together decided that why can't we have engagement session for the fellow professionals from across the country and abroad on some technical and knowledge upgradation objective. And that is how this program was started. And since then, continuously we are continuing, for which I wanted to pay my gratitude to all my friends from various profession societies, all my participants from all over the country and abroad who keep on waiting and attending these webinars depending upon their choice of the topics. Thank you so much. Dear friends, the today's topic is primarily on smart metering. I am aware of the fact that smart metering in many of the states have already been implemented. And when it starts in maybe with not full features, but maybe with limited features. If a smart metering infrastructure comes in a big way, as Dr. Ritika has rightly introduced the topic, possibly the purpose of having a lok adalat by Bijli electric department will not be required. I remember around 8 years ago, when this kind of internet connection was not available, so they used to give us a metering system in our mobile that you keep on, if you have 200 GB in a month, you keep on watching that today how much you have consumed, what is left, and accordingly you may plan either to manage your total consumption within that limit, or otherwise plan in advance to do some top up and have some another data for you. So that's the kind of system, and then there is no fight. Otherwise, everywhere there is a fight, and even in today's time, almost every quarter, and when required, sometime every month, the electricity or discom operators keep on organizing a lok adalat where people go discuss their problem, and finally there is a ombudsman who decides that no, reduce this much, and then people will pay, and finally the issue will be solved. So using technology, if smart metering is being implemented, probably many of the problem of the nation will be solved. Not only this, that related to the customer disputes, also the electricity theft is a bigger issue that will also get identified. And on this topic, on this occasion of 172nd episode of this webinar series, we have invited two accomplished experts from top-notch organization like Landis+Gyr, who will be enlightening us that what is the way forward, what are advantages, and how we can move forward. I'm traveling and going to India International Center for attending another important meeting, which was otherwise scheduled. So attending this webinar on my mobile. Thank you so much. Wish you all the best. God bless you all. And once again, my gratitude to my friend, Mr. Ajay, who keeps me connected with all these accomplished experts and may helping me in a big way for sustaining this webinar series. Dear friends, many of you are aware, and those who are not aware, for your information, in the year 2023, the IEEE announced a kind of nomination for awards from all over world. The nominations were submitted. We also submitted the complete journey of this webinar series. And when the result were announced in 2024, it was adjudicated as the one of the best sustainable knowledge dissemination session started in the backdrop of COVID in entire world. And that credit goes to my entire team and entire participants, and of course my friends like Mr. Ajay, who keeps me connected. And imagine 172nd episode, 172 such sessions, and in many of the sessions there have been two speakers, so 200 plus speakers, top notch from the industry, have shared their experiences on this platform, and the recording of all these lectures are available on YouTube. So how much the people are getting benefited, this is all because the people are at the back end working, the people are connecting to the experts, and it is happening. Thank you so much. I'm sure this webinar will help us to understand how information and communication technology with the help of a smart metering is going to transform the world. Thank you so much. Wish you all the best. God bless you all. Over to you, Dr. Ritika.
Thank you, sir. Thank you for the wonderful words. With this, I would now welcome amongst us our expert speakers for today, Mr. Vikas Gangwar sir and Mr. Dheeraj Kumar sir with an e-bouquet. So welcome to the session.
Thank you so much, Ritika.
This e-bouquet is also part of that change. The way from analog meters we have shifted to a smart meters. In
Yeah,
the same way, this e-bouquet can be termed in coming days as a smart bouquet.
that's
एंड
possible. It is.
एंड बुके का पर्पस है एक खुशबू बिखेरना। और खुशबू के लिए मैंने दो पंक्तियां लिखी थी कि बड़ी मुश्किल में हूं कैसे इजहार करूं, बड़ी मुश्किल में हूं कैसे इजहार करूं, तू तो खुशबू है कैसे गिरफ्तार करूं। तो ये खुशबू है, आप तक
Very
खुशबू
nice, sir.
पहुंच रही है। आप उस खुशबू को आप उस खुशबू के एहसासों को महसूस कीजिए अपने एहसासों के अंदर, और उसके साथ हमारे साथ जुड़िए। जो हमारे पार्टिसिपेंट्स हैं वो भी इस एक्सपर्ट्स को भेजी जाने वाली खुशबू को महसूस कर सकते हैं। और इस महसूस के साथ टेक्नोलॉजी के लिए जो विजन मैंने सोचा है वो ये है कि वो टेक्नोलॉजी के मुसाफिर तुम्हें अभी बहुत दूर जाना है। ओ टेक्नोलॉजी के मुसाफिर, तुम्हें अभी बहुत दूर जाना है। पत्थरों पे पत्थरों पे गुलाब खिलाना है और आंधियों में चिराग जलाना है। तो ये हमारा विजन है कि टेक्नोलॉजी वहां पहुंचे। स्मार्ट मीटरिंग इज अ intermediate step in that. Thank you so much.
Wow.
Very
Thanks,
very
Dheeraj.
nice, Professor Oda. Thank you so much.
Thank you.
Thank you, sir, for the wonderful words. Dheeraj sir is a solution architect and technical consultant at Landis+Gyr. His 14 years of experience in consulting and software architect with TCS and Landis+Gyr have given him extensive experience in solution designing and business understanding for global clients across India, Europe, UK, USA, Japan, Thailand, Hong Kong, and Vietnam. He has good exposure to pharmaceutical and smart metering domains. He has also worked in several key technology areas like the cloud, business intelligence, analytics, and DevOps. He is a graduate in computer science. We welcome you to this session today, sir. Vikas sir is a seasoned IT professional with over 2 decades of experience backed by digital transformation learnings from IIM Indore and an engineering degree in computer science. He has extensive experience in software engineering, designing entire application, complex software solutions, technical program management, and business and cloud transformation. He works as head of customer architecture services with Landis+Gyr. We are honored to have you amongst us, sir. And I would now request Dheeraj sir and Vikas sir to kindly enlighten the house. Over to you, sir.
Thank you so much, Ritika, Dr. Ritika. Highly appreciated. Dheeraj, would you be sharing that presentation, please?
Yes. Thank you. Thanks,
Thank you.
Ritika, and thanks everyone for having us. I will share the presentation and we will start it one by one.
So,
Let
good
me
evening,
know.
everyone. Before I start, I would like to appreciate this platform wherein all the industry leaders, they are forming this group to share and spread the knowledge all across. And since this was formed somewhere 5 years ago during COVID time, it makes a real sense in the value of technology that VBI CAM is nurturing to all the industry folks, right? So this is a great work, highly appreciated team. Thank you so much. All right, so today's topic of the session is advanced metering infrastructure of or AMI in acronym sense. Especially this session would be concentrated towards more of RF mesh technology. So there are various technology, but we'll especially touch the RF mesh technology. Next slide, please. Yep. So we'll follow the following agenda for today's session. We'll start with gathering some of the thoughts for energy, smart metering, and technology. I understand that Dr. Ritika and Dr. Professor Oda, they already shared their views about smart metering and part of the technology. So we'll try to cover pieces and we'll try to join the end-to-end journey for this technology and smart metering piece. Then we'll move on to the understanding of AMI solutions, their examples and different use cases that are available within the market these days. And gradually we'll shift our focus to AMI 1.0 and 2.0. Those are the transformative change for AMI solutions at a very high level and how the AMI future looks like in coming years. So this is what we'll be following. Next slide, please. All right, great. So I have been told that in today's session, most of the attendees are from academia piece. So almost 90% of our participants are from that area. I have, since the major audience for today's session is from a different discipline, hence I would like to start the session by asking a few questions about these two pictures. Since your mics are muted, if you could text in the chat window about these two pictures, who they are, I think that would be really helpful, right? I'm trying to join the dots in terms of the entire journey back to one of the most transformative periods in human history. And this is nothing but the electricity or electrical discovery and the birth of modern innovations that we are kind of building now, right? So, okay. So the first image is from okay, so we have Benjamin Franklin as one person, and the second second person is none other than Thomas Alva Edison, right? He is known for his invention to electricity bulb, which is more of the commercialized version, right? He later formed an electric utility to compete with electricity supply and to compete with the existing gas and electricity units during that time. The second picture, as Ajay told, it's none other than Benjamin Franklin. But since we are talking about, let's say, this electric journey and smart metering, why do we have Benjamin Franklin here? He was one of the pioneer who actually discovered the electricity, and I'm saying discovered the electricity during 1752, wherein Dheeraj, next slide, please. Wherein Thomas Alva Edison invented the electricity bulb. So the story of electricity begins with is not a single man's journey, but it is a century of curiosity of humankind, wherein ancient Greeks started with static electricity, and then in 18th century, let's say, Benjamin Franklin came and did his kite experiment, and then discovered that there is a even in lightning there is a electricity available, right? And gradually in 1879, Thomas Alva Edison had invented the electricity bulb, which gave us the lights, right? So it actually lights up the entire world, literally. Next, wait. I think, no, go back, Dheeraj, sorry. All right. So Edison was one of the most renowned inventor. He uh, he used practical exposure and experimentation about bulbs to keep it into the perfect shape, using the carbon filament and creating a vacuum inside the bulb so that it can be commercialized. It's not like as if the bulbs were not available prior to this, right? They were not available in that shape wherein the electricity can be commercialized or viable for safe use. So his invention turned the nights into day and sparkled the electrification of modern society that we are having now. Next slide, please. All right, but this invention of light actually started another beginning for us, and that beginning was, how do we deliver electricity to homes, factories, or cities, right? And that's where I think now we are having electricity transmission related evolution. So Edison himself, when he invented, it was more of the direct current related supply, which was not for long duration or long distance stuff. It was more of short distance supply. So during those days, the model was very simple. You generate the electricity as much as possible, keep the lights always on, and if you have the power to cache, you can utilize this light. But for the other places wherein the cache is not available or the distance is far, I think this model was not exist, and they were still in dark, right? So from that time onwards, we realized that we need a smarter way to generate as well as transmit the electricity gradually. So the picture that you are seeing is more of old times transmission grids, wherein they were supplying the electricity. There were less and less of supply and demand uh, for foresightedness in terms of how the supply and demand would be, and lack of real-time monitoring for the entire electricity as well as the demand. So the problem was, though we had identified how the grids would operate, how the supply would go to, let's say, different places, but our problem was how to monitor it, how to handle the balance, and see how the infrastructure would be handled going forward. And that's where the smart grids come into picture. Next slide, please. So from the birth of smart grids, now you would see that all the virtual plans or central plans are there in this picture, and they are delivering and transmitting the supply to homes, offices, and industrial plants. The metering is feeding the commercial processes overall, and to some extent providing the real-time data. And I'm saying to some extent because most of the utilities, I would say in India, they are not there yet, though there are solutions available to have this operational processes optimization part, as well as to identify appropriate technologies from smart metering side or metering side, as well as the backhaul or communication layer, and then from the solution side of window, right? Next slide, please, Dheeraj. So the effective transmission and generation we started, but the technology improvement and refinements is a continuous journey. So this image, if you would see, this is more of digital age transformation related stuff, wherein it's not just the smart metering or AMI solution, it's a combination of several other factors. We have to handle the demand and response. We have to handle advanced metering related features from the meter or to edge to the backhaul to our own solution window, whether it is in cloud or on-prem, and smart metering communication also. And then whatever information we are receiving should also have a data analytics management or meter data management kind of stuff. And then the distribution should also be automated to some extent, which we are gradually moving forward with. So these are some of the initial factors, just to give you a brief about how the smart metering and technology looks like from the industry point of view. Now Dheeraj would take it over from here and will share the AMI or advanced metering infrastructure components, and then we'll jump on to AMI 1.0 and 2.0 related use cases. So over to you, Dheeraj. Thank you.
Thank you. Thanks, Vikas. And it was a really informative one. Let me go quickly to the next. Somehow my mouse has stopped working, so I have to do it manually. Okay. So I think we already had a lot of introduction onto the AMI, so I'm not going to eat a lot of time. But as Huda sir have also mentioned, Vikas sir have mentioned, and Ritika have, I think, mentioned more about AMI than we even wanted to. So thanks for that. So yeah, this advanced metering infrastructure, first of all, like we need to understand what it is, why we are actually using it, how it's going to help us. And the very first thing which Huda sir mentioned in the start of our meeting or start of our this call, that's the very first thing, like to stop the power wastage, to ensure that we are avoiding the loss, the theft, I would say. I would rather be a bit conservative, so I would put loss there. And to ensure that how we are utilizing the power in a most optimal way, not only the consumer, but the producer also, how they are benefiting it. Because as of now, if you have seen like last 5 year or 10 year, and if you read the news, if you go to the website, you'll see, oh, this particular power company is in loss of this much, this particular power company is in loss of this much. So those kind of things we have to reduce it, how we are coming it, what we are doing it, and how we can make it better. So that's where the entire advanced metering infrastructure comes in picture. Now onto this, like advantage we have already talked, and I will give couple of like real-time example from our India culture only. So reduce the power theft. Like I have seen that, a lot of you have also seen that in past. Even we used to have the digital like electric meter. You might have heard somebody have put the magnet there, the meter reading stopped. Somebody have put the wire there, this has stopped. So advanced metering eliminate all of those kind of uh, power theft and other thing. You won't be able to temper the meter. If you are tempering the meter, immediately, like into the same second, the company will be notified that your meter have been tempered. They can send a person there. So that's the most powerful feature you have. Then again, improve the billing and accuracy. As Huda sir was mentioning, we are trying to avoid that lok adalat for settling out those billing and other things. So in AMI 1.0, and also Vikas mentioned, like we might not be using as of now in India the full capability of AMI 1.0, but it do give a feature to manage your billing in a very real time. So even in now in Noida, you will see, or into the bigger city, you will see that you have that Power Grid and app, like you recharge the prepaid meters, you will have the power consumption until you run out of the money, and then you recharge it, your power gets restored. So those kind of thing is being done. It's not widely spread in entire India, but it's getting very fast there. Like in Bihar, in UP, in Gujarat, like we are deploying millions and millions of such meters to ensure that we have those prepaid and other things. Better revenue collection. Assam, like I think 3 months ago, you might have read the news. It was a big talking point that Assam Power have achieved 25% increase into their revenue, and they have multi-crore benefits. The first time into the history, they had a so huge benefit. That was due to the AMI implementation. And Assam Power is one of the very fast adapting power provider in India who is encouraging the advanced metering. Data management planning, we did talk, like in Gujarat we have, in Maharashtra we have, and when I say better management planning, like in India, maybe in summer or maybe in winter, our power consumption is different. Like in day, we run the AC and other thing on a very high mode. In night, it may come to a bit less. So what company is opting is like when the power consumption is more, they have the normal tariff and other thing, but to avoid the other power wastage, when they analyze by the data that okay, this particular time or this particular time frame they have a less power consumption, let's say at night from 11 p.m. till morning 6 a.m., they feel like okay, all of the office is closed, the power consumption is a bit less. They tends to reduce the traffic tariff, sorry, not traffic. They tends to reduce the tariff, they will reduce the bill, so that they encourage the people to use the power for like ad hoc activity during that time. Let's say you need to run the washing machine, you need to run some other things, you need to do some heavy work, so you can do that time. So that is the tariff management there. Okay. Restoration of power. If something happened, something went wrong earlier, like in a not very old days, like maybe 5 year or 10 year ago, if you used to had a power cut or maybe due to some storm or something, the line got broken, somebody used to have pick the call, like pick the phone and call them, hey, I'm not getting the power. Can you check the power line? Can you check this thing? You used to call into the power grid. Now, with the advanced metering infrastructure, you don't have to actually. The point the power get disconnected, the company will know in which area the power is disconnected, in which household it's disconnected. They have that much of information. They can leverage those information using the infrastructure, what we have now or what we are deploying. And it's actually maturing day by day. It have like a lot of feature coming on. We can build the app, another thing which we will discuss onto the AMI 2.0 upcoming. But we have to know, like we have moved from the phase where we need to call to the power provider that I'm not getting the energy from last 2 hour or 10 hour or sometime maybe even day. Now they know within the seconds that okay, this person don't have the power, they will analyze the issue and they will fix it for you. So yeah, those are the major advantage. There are a lot of the advantage, but we are not going to discuss that each and everything. But overall, I would say these are the major points for the advantage. Now I'll briefly touch onto the technology, like what technology we use to get the data from meter. We are talking a lot, we are acronyms like advanced metering, AMI. But the question is how company are getting data from your house. In your house, you have the meter, how they are getting that data from your house to their system. They don't have like direct communication of cable or other thing, right? So we do use the different methodology. The very first, and it's quite old, which is PLC and PLX, where the reading of your consumption that used to come with the power line itself. The power line, which is uh, come to your house, like they used to send the data using that power line only, and like they used to get the data, company used to get those data, but there were quite a loss actually. On an average, it was estimated that they have almost 10 to 15% of data loss there. So we are moving from that PLC and PLX. Even in India, we have moved a lot. I don't think even we are using 10% PLC, PLX now anymore. And not only in India, but all over the world, we are reducing the use of PLC, PLX to avoid the like loss of power and loss of data. The prominent technology, what we have is the next all, which is called RF mesh and RF mesh IP. These are actually the radio frequency based communication. So each and every government had set their range on which the advanced meter can communicate so that it's not interfering with any other radio communication. And that wavelength, that frequency is actually used by RF mesh and RF mesh IP. They have a slight difference actually. When you see the name RF mesh and RF mesh IP, you might say, okay, what is the difference? So the major difference, what you have in RF mesh and RF mesh IP is the intra communication. So, and without going to the technicality, like I will give you a very practical example in house, not for the meter, but maybe for the internet side, which might be able to understand. So when I talk about RF mesh, you have many phone, laptops, and other thing which you use in your house. If you have to connect to the internet, basically you are connecting with your router, what you have in your house. You just connect with your router. If let's say my router is onto the ground floor and I just hop into the first floor or fourth floor, I tend to get the less signal, or maybe sometime I get disconnected. Okay, so this is a kind of RF mesh technology where every device is connecting to one source to take the data and provide the data. Whereas in RF mesh IP, what I can do, I can communicate with my neighboring device. So let's say I have 10 phones in my house, I have one router. How much good it would be if even if I move to the fourth floor and if I'll try to access my internet, I can try to access the internet with my neighboring device, maybe my wife's phone, maybe with my friend's phone, and I can get the internet using the same router. So that's how the RF mesh IP topology works. Even if the meter is unable to communicate with the concentrator or the source, they can communicate to the next adjacent meter. They can provide their data to that meter, and that meter can send it away. Or if they are also unable to communicate, vice versa, they will send it away to the next thing. So that's the major difference we have in RF mesh and RF mesh IP. There are a lot of other things also, but to give you a holistic picture, I just leverage that example. I hope that's helpful. The next three is basically the cellular one. The M2M and LTE, these are the scene-based, like we are doing the cellular, and Wi-SUN is the latest addition onto the cellular, which is a lightweight cellular communication, but these all follow the cellular mechanism to communicate. Again, when we talk about this communication, there, like you have to plan and you have to analyze which communication and other thing you will use. The reason behind not every area have the cellular thing. So it's depend where we can achieve the cellular communication and where we want to apply that radio frequency. So it's depend on to the area and area wise. For the RF mesh technology, like what we have talked here, I think this is the repetitive one. It's a wireless communication, which I said that are radio frequency based. Again, each meter into the network act as a transmitter, like they can receive and transmit the data for each other. This entire communication is based onto the IPv6, and that give us a leverage. That give us a leverage to like have millions and millions of devices deployed into the system, because we all know, like as of now, as per the current system or the infrastructure, we have almost, I think, if I'm not mistaken, a million of IP per square feet for the IPv6 in the world. Okay, per square feet of land can have a million of IP for the IPv6. So we are using IPv6, and I think we are not going to run out of it anyway. So that's why it gives us a leverage to scale a lot and lot. And again, onto the communication, it's a radio frequency network, ensuring that even one communication gets failed, you can communicate to the adjacent one, the second adjacent or the third adjacent one. I think we did touch this part into the advantage area, like the network reliability. Even some communication, let's say if one of the meter communication get broken, if it is not able to communicate to the concentrator, or it's not able to communicate at all to the grid, it try to self-heal it. Like it will keep trying until it have established the connection. It could be a minute, it could be an hour or so. As soon as it get the connection, it will send entire past data to the system. So it have a self-healing capability. Like you don't have to send any agent to that particular area and okay, look what happened to the meter. I'm not getting the data. Now it's not like that. In a very rare case, you have to send some physical appearance there. Otherwise, the meter will do the self-healing. If it have any other event, not only for the connection, but if it feel like it got, let's say, some encryption issue or some data related issue, if it is receiving some garbage, it will throw it out. It will inform the system that, look, I'm not receiving what I expected to receive, so that you can take action accordingly. Coverage, I think we have already discussed a lot about the IPv6 and other thing, how vast it could be used. As of now, I did use one of the terminology, which is called concentrator or collector. So it is basically a source, just like a router in your house, with whom you actually connect all of the device. So in our advanced metering infrastructure area, we call that as a concentrator. And one concentrator actually can connect to the 5,000 meter or so. So if I'll put one concentrator, let's say in one of the society, I might be able to get the data for entire society for all of the household meter. So that is called concentrator. Again, the latency, we have very, very fast communication over the radio frequency. Security and encryption, we do follow that AES methodology, TLS encryption, as well as on top of that, we have every country's government authorized encryption method, which can be implemented to transmit the data. So it's very hard to, let's say, hack those. Maybe 4 or 5 year or 8 year ago, we used to hear that this particular country have hacked the smart grid for this particular country. They have bought it down. It's pretty hard now for that. Again, cost effectiveness. It is pretty cost effective than the cellular one, although the cellular one also work really well, but it itself has a bit of extra cost because you have to, like energy provider have to pay to the cellular provider as well for the communication. For the cellular, every communication happen over the SIM. So you can imagine like there will be some price to pay for that. So that onto the advantage side. Now onto the AMI 1.0 and 2.0. So as Vikas was mentioning earlier, we are improving. We are actually, let's put it in that way. We have started from a desk telephone. We went to Nokia 1100. Then we had the Android phone. AMI 1.0 is the Android phone. Now imagine that AMI 2.0 is AI-powered Android phone. It's know what you want. So those kind of things we can achieve with the AMI 2.0. How good it would be that your meter have an app in your phone and it will say that your AC is consuming this much, your refrigerator is consuming this much energy. Let's say if your AC used to consume 10 unit, just hypothetical, it should not take 10 unit, but I'm being hypothetical. So if it used to take 10 unit, let's say, in a week, and suddenly it's a spike to 15 or 20, how good it would be that your meter, your app notify that something is wrong with your AC. Get it checked because it's consuming a lot. So those kind of thing also we can achieve with the AMI. We are already working on that. We are already doing it. Like especially in Europe and in US side, we have implemented like AMI. I won't say the 2.0 completely, but it would be kind of between 1.0 and 2.0. It's kind of 1.5. You can control your energy consumption and everything using your mobile phone. So if you are not in your home, just put it that I'm away, it will take care of each and everything. It will ensure that on this time frame, your fridge need to be powered on. That's it. It will ensure that up to this point, your water heater need to be powered on. That's it. So those kind of thing can be achieved. The other part is onto the data actually. It gets lot of data from your system. As I was mentioning about the example of AC, the example of fridge and other thing. So it do the analysis based on to the data received from your house. So it's a completely power of data there in AMI02. Uh, Flexibility, yeah, similar to the smartphone, you have the apps. You can develop your own app if you don't like the app. Let's say the dashboard, another thing, what company is providing to you. You have just like the iPhone App Store or Android App Center, Google Center, where you go, you download, or even if you have created some app, just publish it. If company may like it, they will also use it. So those kind of things we can do with AMI 2.0. A couple of technical points onto the AMI 2.0. It's edge computing, the enhanced cybersecurity, efficient battery. Again, in meter, we used to have the battery as of now, like it's a 8 hour to 24 hour powered on. But in AMI 2.0, the new meter switch is coming, it can be powered on like a month or 2 months or so, even if you have some disconnection there. It can store all the data of 6 months. As of now, we have 30 days, in some case 45 days, in some case even 24 hours. The data is stored in meter. But now in the new meter type, you can store the data for multiple months or weeks. The last one, I think it's a use case and implementation. So for the real-time energy monitoring, enabling that remote meter reading. So with the advanced metering, you don't have to send your person to do the meter reading. Even as of now, you might be seeing, although for the energy meter, for electric meter, we don't used to get a physical appearance from the power side, they get the reading. But even like in Delhi as well, like gas meter people used to come, okay, I need to take a picture, I need to get a reading. So those kind of thing will be taken care automatically. You don't have to send anyone physically to do anything. So those things will be the implementation and use case here. Uh, it also helps the outage detection. So if there is any power outage in any area, it will get notified that, okay, this power outage happened, please take the necessary action. Uh, the one feature we talked is a two-way communication. It will mainly help you onto the solar power consumption. So nowadays you might be hearing a lot from the government that even you can supply the power to government. Okay, you have the solar panel, you are using it. If you have the extra power generated by your solar panel, you can sell that to government. So how you will sell that? You are just giving back the power to government, but you have to track those things, right? Where how much I gave, how much I used. So those things can be tracked by meter and it's being tracked. It's improving day by day, it's being tracked, and that's how you are getting paid. So those kind of use case we have, we are already implementing those. A lot of point what we have discussed, we are already implementing in several states like Assam, Jammu Kashmir, Bihar, Uttar Pradesh, MP, Gujarat, Delhi, like in a lot of states we are already implemented it, we are implementing it, and we are moving ahead a lot and lot. Yeah. So you might see in coming time, maybe in 10 years, government have already published a couple of their use case and other thing. You might see a drastic change in our advanced metering capability in India as well. India is still a growing market for advanced metering infrastructure, and the people are adapting faster than we think. Actually, we may have the like if you would have asked me, let's say 10 years ago or 8 years ago, will we be too comfortable in using it? I might have had my own reservation, but I am pretty surprised how fast we are adapting this advanced metering. And maybe in a 5 year or 8 year of time, we might be on a level of Europe and USA into the advanced metering. Hopefully, if everything goes good. So yeah, I think that's all I had. Yeah, thank you. And if there's any question, we would love to have it. Yeah.
Thank you, sir. Thank you for the enlightening deliberation. We surely have certain questions by the participants, which I'd like to now take up with your permission.
Please, we will be.
Sure.
Yeah.
So the first question we have, in India, how much is the usage or coverage of the smart electrical meters? Like you have said that we are adopting fast, but
Yeah.
still, how much would be the coverage?
So,
Yeah, go on, Vikas.
yeah, Ritika, just to let the audience know, Government of India, as part of RDSS scheme, which is nothing but revamped distribution sector scheme, they launched this scheme, I think, 3 years back, and there is a target of 250 plus million meters, smart meters conversion program. So all the AMISPs, they are in process of handling these smart meters or older meter conversion to smart meter within India itself.
Absolutely.
Yeah, and then if we take, let's say, examples of all the metros, whether it is Delhi, NCR, Bangalore, right? Smart meter conversion was always there. As soon as we were growing, the smart meters were already there. So this 250 million would be primarily to the rural or urban areas.
Okay.
Mhm.
That's great, I
Yeah.
think.
And just to add, like, if you want to know the so far implemented, we have already reached in India up to 30 million. So 30 million smart meter have already installed. And yeah, as it's mentioned, it's going on.
And I think that is a wonderful number that we have. But
Mm.
with that comes another query that we would like to know. These AMI systems, like as you have already told, they collect and transmit all sensitive energy usage data. But that will make them more vulnerable to cyber attacks and data breaches. So
Yeah.
how is that controlled?
Oh, that again, that comes the encryption part, another thing, the data encryption. And again, the data what company is getting from you, you have the control during, like when we talked about the AMI 2.0 and other thing onto the app development and other part, you will have the control on your data. You are not going to share all of the data. Okay. You will only share the analogy and you will only share those data what you want. Company mainly need the overall usage data from your side. Until unless you are giving the consent, okay, let's analyze my data. They won't. They just need to get paid actually. Like, so they want to know you have used 2 unit. I'm billing you for the 2 unit. But if you will give them the permission to use your data to analyze your usage and suggest you what you can do to save those, then only they will get your data. That is onto the data privacy. But onto the data security, this advanced metering actually use 4 layer of encryption. We have an encryption onto the meter itself. We have a network layer encryption, and we have an encryption onto the data on rest, and then onto the data transfer you have. So we have a multi-layer of encryption, and it could be, I would say, there is nothing impossible. So I'm not going to lie here like nothing will happen. But yeah, there is a very few chance, like maybe 1 in a billion, that it might get hacked up to a like 5 or 6 layer of protection you have there.
Absolutely. Sir, I think there would be another very common issue, especially in India, that we would have that with the smart meters, people can peek into the usage pattern time of the day. And the same could be used for assessing that what time the occupants are at home, etc. So how are these issues actually controlled?
Again, like if you are asking about the privacy area, like if somebody will track if I am on home or not, that again come to your data sharing part. Do you even want to share those data, or do you just want to give the holistic data to the company? But if you see the other part of this coin, like, okay, I'm not in a house. I want my energy provider or my app to control my usage for me. Let's say I went out from my house. I don't want to do this switch and switch off manually, or I may forget sometime. I want to give a limited permission to the my app to do those things. So as soon as app realize that okay, nobody like this time you don't used to be at home, they will try to switch you off for you. They will try to save the money for you. So it's again depend like what you want to share, how much leverage you want to take. If you want to have the privacy as like we do in our phone, just switch off the location tracking and other thing. The same way you will switch off the elaborated data analysis. You won't be giving them. Yeah. So those kind of thing you will be doing it.
Absolutely, sir.
So another
Yes, sir.
another key factor here that whenever we are sharing this data back to utility via our transmission mechanism, what we are sharing is, or what utilities are sharing and then grabbing is about your consumption in let's say every 5 minutes, 10 minutes, or in a day, right? We usually don't share and transmit the geolocation or location of your meter per se, right? We usually don't handle whether you are in a house or what all equipments are happening, at least within India, right? So because of DPDP Act, till the time you're not giving the consent, utilities won't touch. But then there is another angle to look at, and then we have seen this pattern in Europe also, that till the time India has a fixed unit billing rate is all okay. But if we have to utilize our energy production and have to distribute the load accordingly, basis of the tariffs that Dheeraj was talking about few minutes back, till the time this pattern is not available in which season the consumption of electricity is going up or down, and at what point of time the consumption is up and down, these tariffs may not be launched. At the end of the day, these tariffs would help the end customer itself, right? During the day, let's say energy consumption is low and the prices are also low, right? If the energy consumption is going high, maybe the tariff prices would also go high, right? So that kind of pattern will be available if the tariffs are there. But as such, from the data privacy or customer privacy point of view, none of the parameters that are passed from your smart meters are from your PII or personal identification information related stuff. It's just the meter ID and that's it. Nothing else. It's
Absolutely, sir.
mostly your energy consumption patterns.
Absolutely, sir. So
Mhm.
one last question I would have, because of the approaching summer, the high temperatures we have. With the conventional meters, we have generally seen cases, and especially cases during summer season, where the meters actually catch fire. How safe are these advanced meters for these kind of weather patterns as such?
That's a really good question,
These
Ritika.
meters, when we share with
Climate in
utilities,
general rather than only the
yeah.
Absolutely,
So
sir. But that is one query I have, because we have in Delhi, I would say, we have already started facing those higher temperatures. So come June and July, we don't know we are even going to cross 50 degrees.
No. See, what happens is in this particular case, it is an environment which is going to matter more. It's not only the heat, it's severe cold also, the humidity, this and that, raining and machine entering and everything, because it's all electronic and also the software and other things. So from that angle, if we say how it is in the adverse weather condition, whether the system will probably
So,
built-in AI will take care of that also. That's a different issue. But that's
yeah, AI is one
precisely
piece.
we should look for the answer.
AI is one piece, but whenever we are creating these meters or building these meters in our factories, there is a metrology test that we are doing with those meters, right?
Those systems may
So,
be hermetically sealed.
yep. So whether it is water or flood related stuff, whether it is short circuit related stuff, whether it is heat related stuff, we test those meters and then we deliver them to utility. Even I have seen some utilities on top of our test, they test those meters before deploying to end user. So it's not something that the meters will catch fire because of heat, because we tested them. We know what kind of temperature they would be.
Some cooling system has to build it.
Yeah.
To
So,
work under adverse condition, and hermetically sealing for the moistures and other things should be part of it. And little bit, if you say adverse, could be even the mechanical side, stress and strain and other things, probably those can be also be taken care. So that depends
Yep.
on the mechanical design part of that.
Yep. Agree.
Yeah. We call that as a closed chamber test. So you have, and this parameter gets changed every year based on to the like changing climate condition and other thing. So we do have those test parameter, closed chamber test for heat, for cold, for rainy season and other thing. So all test
Maybe
meters are
depending on the area also, we can say that Mark 1, Mark 2 or something of that nature, that okay, this will work for these adverse conditions, this is okay for this one and another thing. So that
exactly.
it's something equivalent of we say commercial use or military use or adverse condition use. So those can be tailored that way so that the cost effectiveness comes.
Yeah.
If everything is built that way and it is not needed, it's a waste of resources and the money part of it. So maybe we can have different grade to the meters.
Yes, sir.
Exactly, sir.
So thank you so much, Dheeraj sir and Vikas sir, for this wonderful session we have had today. And I would say simplistic but yet wonderful way in which you have shared how this smart meter, advanced metering technology is actually growing. It has been a wonderful session that we have had, and we have come to an end to this wonderful session. Not before we will thank you. Huda
Yeah.
sir had to leave for that important meeting. But please accept this certificate as a token of remembrance from for this wonderful session from our side today. Thank you so much,
Thank you so
Vikas
much,
sir,
Ritika ji. Thank you.
Thank
and
you.
thank
Thanks a
you so
lot.
much, Dheeraj sir.
Thank you.
We
Thanks,
also
Ritika.
have, thank you, sir. We also have a small e-memento. So I would say after this session, I would say more, it would be a smart memento that we have made for the session today.
For the smart deliverance of that task.
Yes, sir.
Oh,
Yes,
So
very
please
nice.
accept this e-memento also.
that's really nice.
Yes.
Thank you, Vikas sir and Dheeraj
Thank
sir
you so
once
much,
again.
ma'am. Thank you so much.
Thank you.
Highly appreciated.
Thank you, sir.
Really appreciate it. Yeah.
So,
Thanks
dear
for having us there.
participants, thank you, sir. Dear participants, with this, we have now come an end to this wonderful session today on advanced metering infrastructure. And the feedback link for the certificate of participation generation has already been shared with all of you. I thank our speakers, Dheeraj sir and Vikas sir, for taking out time from their busy schedule. Dheeraj sir has connected with us from America. Thank you so much, sir. So thank you so much, sir, for your participation and the wonderful way in which you have shared knowledge with our participants today for this session. We hope to
We can
connect
tell him,
with you
we
in
can
the
tell him
future
good
once
morning, not
again.
good night.
Yes, sir.
It is good morning. But yeah,
Yes, really good morning for you.
yeah. Thank you. Thank you. Really appreciate it.
We hope to connect with you soon in the future with another wonderful session. Thank you so much, sir.
Thank you.
Bye, guys.
Thank you, sir. Thank